All right, so for about 100 years now, we've all been grappling with quantum mechanics, right? It's this theory that's just so weird, it feels like it breaks reality. But have you ever stopped to think about the story behind the story? Like, how did we even write the rulebook for this bizarre new world? How was it taught? Well, today, we're going to pull back the curtain on that hidden history.
I mean, seriously, think about that. How do you teach a theory that just completely defies reality? It's the ultimate challenge, isn't it? We're talking about a world where tiny particles can be in a bunch of places at once, and just looking at something literally changes it. How in the world do you write a rule book for that? Well, the answer isn't where you'd expect. It's not in some fancy lab or a giant particle accelerator. Nope. It's actually found in the evolution of one single, surprisingly powerful object. The textbook. Yeah, you heard that right. The whole story of quantum mechanics is really a story of literature. And these books, they didn't just write down what happened. They actively shaped the revolution. They guided it. They defined it for every single scientist who came after.
So that's what we're diving into today. This is a theory told in books. We're going to look at what you could almost call textbook speciation, this wild idea that the books themselves evolved over time, almost like different species, each one adapting to the specific scientific and even political climate of its era.
So, here's our game plan. We'll start with what I like to call the sacred texts from the founders. Then we'll jump to how the Cold War forced a huge shift towards just pure calculation. After that, we'll look at the move towards actually making this stuff understandable for students. And finally, we'll see how today these books are all about programming a new reality. And this timeline right here, this is our roadmap for the journey. We've got 4 major eras, starting from the heroic age all the way to today's information revolution. And what's wild is that each of these periods had its own unique mission, its own philosophy, and its own iconic books that literally defined how generations of scientists thought about the universe. Okay, first up, the founders' sacred texts. We're talking about the heroic age, from 1925 to 1935. Now you have to understand, these guys, they weren't writing for undergrads. No way. They were writing for each other. They were frantically trying to build a logical, coherent rulebook for a theory that was literally being born right in front of them. These weren't textbooks. They were manifestos for a new reality.
And at the heart of all this, you basically have 2 pillars, 2 giants. On one side, you've got P.A.M. Dirac, the physicist's physicist. This guy created a whole new language for the theory, that elegant bracket notation that's still everywhere today, and he managed to unify all these competing ideas into one powerful system. Then, on the other side, you have John von Neumann, the pure mathematician. He came in and provided the absolute hardcore rigor, planting the theory on this unshakable foundation of abstract math, and, just casually defining the infamous measurement problem.
And Dirac's book, wow, it was seen as a total masterpiece. This quote just nails it. A work of austere beauty. I mean, people compared it to Euclid. It wasn't just another science book. It was treated like a piece of pure logical art. It took this completely radical new vision of the universe and laid it out with the kind of clarity you'd expect from ancient geometry. Just incredible. But that whole vibe, it was about to change. Big time. Because after World War II and the dawn of the nuclear age, the game was completely transformed. The purpose of the quantum textbook was about to get a radical rewrite. And this quote right here pretty much became the unofficial motto of the whole post-war era. Shut up and calculate. It perfectly captures the new mood. All those deep philosophical debates between guys like Einstein and Bohr, yeah, they were shoved to the side. The Cold War was on, and the world needed engineers and physicists who could build things. Nuclear reactors, transistors, you name it. What mattered was getting the right answer. Not wondering what it all meant.
And the book that absolutely embodied this new philosophy was Leonard Schiff's Quantum Mechanics. For 30 years, 3 decades, this was the standard. It was pragmatic, it was dense, and it was laser-focused on one single thing, training students to crank out complex calculations as efficiently as possible. It was basically the ultimate training manual for the Cold War's scientific industrial machine.
But you can only do that for so long, right? By the 1980s, a kind of rebellion started brewing. A whole new generation of professors looked around and thought, you know what? This shut up and calculate thing is just soulless. It stripped all the wonder out of the theory. So this led to what's now called the pedagogical turn, a movement to write textbooks that actually help students understand the crazy concepts, to build intuition, not just to plug and chug equations. And the master of this new approach, the person who absolutely perfected it, was David Griffiths. His textbook became the undisputed king of the undergraduate classroom. And for a simple reason. It did something totally radical. It actually talked to the student. It used this friendly, conversational tone. It built up the weird ideas step by step. And, this is the magic part, it seemed to know exactly where you were going to get confused and would address it right there on the page. All right, get ready for the next big leap. Because just as everyone was getting comfortable with this new way of teaching, another, even bigger revolution was kicking off. As we hit the 21st century, quantum mechanics started to morph from a theory about matter and energy into something completely different, a theory of information. This is where things get really wild. And if you need one book to mark this new era, it's this beast right here, Nielsen and Chuang's masterpiece, affectionately known to everyone in the field as Mike and Ike. This book became the absolute Bible for the brand new field of quantum computing. It created the standard language, the vocabulary of quantum circuits, gates, and algorithms that everyone, and I mean everyone, started using to build the first quantum computers. But what's really interesting is that this is where the library starts to splinter. It wasn't just for physicists anymore, not by a long shot. Suddenly, you had all these specialized books popping up for totally different audiences. You had books for engineers, like Dancing with Qubits, and you even had practical manuals for software developers who needed to figure out how to actually write code for these crazy new machines. And that's the key, right? This wasn't just abstract theory anymore. People were in labs building actual quantum hardware. So the textbooks had to shift to solve messy, real-world engineering problems. Suddenly, a topic like decoherence, which is basically how the delicate quantum magic falls apart when it touches the normal world, it went from being this weird philosophical idea to being a critical, #1 engineering problem you had to solve. Which brings us right up to today, to the library of tomorrow. Because this whole evolution, it's speeding up. It's happening faster than ever, and the entire library of quantum knowledge is transforming right before our very eyes. Just look at this number. Over 1,500 pages. That's for one upcoming book. And get this, it's not even a physics textbook. It's an industrial encyclopedia. It's a massive catalog of the entire quantum technology ecosystem, written specifically to bridge the gap between university labs and venture capitalists. The scale is just staggering. This chart really tells the whole story in one simple picture. Look at how the focus shifts over time. Back in the day, it's all about foundational physics. Then you see that big bump for student-friendly teaching in the late 20th century. And now, look at that third bar. We are in an era that is completely, utterly dominated by engineering and software. And that, right there, is the ultimate takeaway from all of this. The entire purpose of these books has fundamentally changed. For the better part of a century, the goal was to help us understand the nature of reality, but today, the goal is to give us the tools to program it. So it leaves us with this pretty profound question to chew on. The founders 100 years ago, they wrote books to try and describe this incredible reality they just discovered. Now, a century later, we're writing a totally new kind of book. It's not a description, it's a manual. It's the code for building machines that can manipulate that reality on its most fundamental level. So the question isn't just what is reality anymore. The question now is, what can we make it do?